South Africa is home to some incredible rivers: the Vaal, the Tugela, the Limpopo, the Great Fish. Each one tells a different story, but there is one that does something no other river can. Meet the Orange River. What's remarkable about it is that, by nature's rules, much of its water should be useless to us. Look at a map. The river starts high in the mountains and heads west through some of the driest parts of the country, straight towards the Atlantic Ocean. Nature's plan was simple: let the water flow to the sea. But South Africa had a different plan. We didn't accept the map. At the heart of that plan are two giants, the Gariep and the Van der Kloof dams, the largest and second largest dams in South Africa. Most people see them as huge walls of concrete, but they're actually South Africa's biggest water storage tanks. Without them, we would have too much water when it rains and not enough when we need it. When the river is flowing strongly, these dams capture the water that would otherwise end up in the Atlantic Ocean. Then, months later, that same water is released exactly when we need it. But it doesn't stop there. Through tunnels, canals, and pipelines, we pull that water out of the river and send it to places nature never intended it to go. Farms, towns, mines, and entire regions that would struggle to survive without it. Think about that. The fruit you eat, the water that comes out of your tap, and the industries that keep our economy running often depend on water that was originally on its way to the ocean. We intercepted it, we stored it, we moved it, and we put it to work. That's why the Orange River isn't really just a river. It's South Africa's largest plumbing system, a 2,000-kilometer long survival machine, quietly moving life across every single day. Every single day, millions of South Africans depend on the N1 to move goods across the country. But there's a second invisible N1 that is just as critical to our survival. Meet the Vaal River. If you live in Gauteng, the economic heart of South Africa, this river is the reason you're here. It supports nearly half of our population and generates a massive chunk of our entire national economy. But there's a strange reality about the Vaal. It is physically too small to do the job. Nature's rules were not designed for an industrial hub this big. The Vaal has been pushed to its absolute limit. So, how does a small river support a massive economy? We didn't accept the map. We turned the Vaal into a massive centralized distribution engine. At the heart of this system sits the Vaal Dam itself, the central storage hub that holds the water for our cities and our industries. But because the Vaal Dam alone couldn't handle the scale of our demand, we built an incredible network of tunnels and canals to import water from across the country to keep it full. We capture mountain water from Lesotho through the Katse Dam, allowing gravity to do the heavy lifting. But the real engineering feat happens when we look toward the Tugela River. To get that water to the Vaal, we do something counterintuitive. We use massive pump stations to physically force that water up the Drakensberg mountains. We are literally defying gravity, lifting millions of liters of water over the escarpment so it can be stored in the Sterkfontein Dam. This is the genius of the system. We don't just dump that Tugela water straight into the Vaal where the hot sun would evaporate it. Instead, we hold it in the Sterkfontein Dam, a deep, compact reservoir tucked away in the mountain shadows. It acts as our strategic reserve, holding our savings in the shade until the Vaal Dam drops to critical levels. All these rivers, these dams, and these tunnels feed into a complex multi-dam network, carefully balanced to make sure that the lights stay on and the taps don't run dry in Gauteng. When you turn on a tap in Johannesburg, you aren't just using a river. You're using the output of a complex man-made web that spans hundreds of kilometers. Imagine paying someone to push a swing. Now, imagine paying them to pull that swing backwards before they push it again. It sounds ridiculous, right? And yet, every single night, South Africa does something very similar. We use electricity to pump millions of liters of water uphill on purpose. And the reason takes us to the Tugela River. This isn't like most rivers. The Tugela is a giant battery. The river starts high in the Drakensberg Mountains before dropping dramatically toward the Indian Ocean. And that steep drop gave engineers an idea. What if we could use the mountain itself to store some energy? Because here's the problem. South Africa doesn't use the same amount of electricity all day. At 2 a.m., most people are asleep, but at 6 p.m. in the evenings, people get home from work, they switch on the lights, they boil the kettle, they start cooking dinner, they turn on the TV, and they maybe even run a hot bath. Suddenly, electricity demand shoots through the roof. So how do you save electricity for later? At the Drakensberg pumped storage scheme, engineers found a very clever answer. At night, when electricity demand is low, water is pumped up the mountain into a higher dam. Think of it like charging a battery, or even better, like winding up a giant spring. The energy isn't being used up, it's being stored for later. Then, when South Africa needs extra electricity, the process is reversed. The water is released. It races back down the mountain through massive turbines, generating electricity exactly when the country needs it most. The water isn't the product here, it's the storage device. And the higher it sits, the more energy it's holding. Think about that. Every night, South Africa quietly uses electricity to lift water uphill, just so that the same water can help generate electricity again the next day. We are literally using a river mountain range and gravity to store our energy. If you look at a map of South Africa, you'll see that the Limpopo River isn't just a river, it's a border. It marks where South Africa ends and where Botswana, Zimbabwe, and Mozambique begin. But the river has a problem. Nature doesn't care about borders. During the dry season, parts of the Limpopo can shrink dramatically, putting pressure on farms, mines, and communities that depend on it. Then, a few months later, the same river can flood across multiple countries all at once. And here's the challenge. You can't solve a problem like that with a single dam, because what happens upstream affects people hundreds of kilometers away in another country. So how do you manage a river that refuses to respect borders? You build a copy of it. Not a physical copy, a digital one. Think about Google Maps. When you open the app, you're not looking at the real road, you're looking at a digital version of the real road. And that digital version knows where the traffic is. It knows where the accidents are and how long your journey will take. Engineers have now done something similar for the Limpopo River. They've built a digital twin. This is a virtual version of the entire river system that is constantly updated using satellite data, river gauges, rainfall measurements, and weather forecasts from 4 different countries. It's like Google Maps trying to show you where traffic will be next week instead of where it is right now. That's essentially what engineers are trying to do with the Limpopo River. And the consequences are very real. Engineers can test scenarios inside the digital twin before these scenarios happen in real life. What if a major storm arrives next week? What if a drought continues for another year or 2 years? What if a dam releases more water than expected? Instead of waiting to find out, they can test the outcome on the digital river first. Think about that. We have built a virtual copy of an entire international river so that we can experiment on the copy instead of on the real thing. If you look at a map of the Eastern Cape, the Great Fish River looks like a perfectly normal river. But if you were standing on its banks, you'd actually be looking at a lie. Because much of this water flowing in this river doesn't actually belong there. By nature's design, the Great Fish River shouldn't be able to support the massive farming valleys that exist along it today. The region is simply too dry. So how do you grow fruit, support towns, and sustain agriculture in a place that doesn't have enough water? Well, you steal it, not from another country, from another river, more than 80 kilometers away. The secret begins at the Gariep Dam, the largest dam in South Africa. Most people see it as a giant water storage tank, but it's also the starting point of an incredible journey. Deep beneath the Cederberg Mountains is one of South Africa's most extraordinary engineering projects, the Orange Fish Tunnel. At 82.5 kilometers long, it is the longest continuous enclosed aqueduct in the Southern Hemisphere. It is such a massive, precise feat of engineering that during its construction, surveyors actually had to account for the curvature of the Earth to make sure that the tunnel segments met perfectly in the middle. That's how far this water travels underground before emerging in an entirely different river. Every day, enormous volumes of water are diverted from the Orange River, sent through the mountains and released into the Great Fish River. A drop of rain that should have flowed west towards the Atlantic Ocean can end up flowing east toward the Indian Ocean instead. We didn't just move water, we changed its destination. We literally rewired South Africa's geography. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.